All right, so in this problem, we need to find pH, pOH, the concentration of the hydrogen plus ion, and the concentration of the hydroxide ion. Remember, anytime you see brackets with a species inside, that's concentration, or in our case, molarity, moles over liters. So if you notice, 2.0 grams of hydrobromic acid in 120.0 milliliters of solution does not give you any of the four values. So you have to first calculate concentration. Molarity is equal to moles over volume. So what do we have in our equation? 120.0 milliliters of solution. That's our volume. And we know whenever we're doing molarity, it has to be in units of moles per liter. So times 1 liter is 1,000 milliliters, because that's our conversion. 1,000 milliliters equals 1 liter. Milliliters went on the bottom, so they could cancel with the milliliters in the original. 120.0 times 1 liter over 1 times 1,000. And that's going to give you 0.1200 liters as your final volume for your solution. 4 sig figs, because there's a zero, there's a decimal, so trailing zeros are important. So that's our volume. We're looking for molarity, so we need moles. I don't have moles in here, but I do have 2.0 grams of hydrobromic acid. So I can use molar mass. Hydrobromic, hydrogen plus, bromine minus, so HBr. Why did I know not to use bromate? Because whenever there's hydro in front, it means hydrogens and no oxygens. 2 grams of hydrobromic acid have to be converted to moles. The unknown always goes on top. The known goes on the bottom. We know we have grams, and we want moles. To go between grams and moles is molar mass, because molar mass's units are grams per mole. So, hydrogen on the periodic table has a 1.01 AMU. Bromine has 79.10. So 79.10 plus 1.01, 80.11. 2 decimal places for that. And 2 divided by 80.11 gives me 0.02497 moles of HBr. Magnitude, units, species. Right, sig figs, we have 2 sig figs, so our answer can only be 2 sig figs, 0.25, because that 9 is going to round that 4 up to a 5 moles. Right, so now we have moles and liters, so we can go back to our original equation. Molarity is moles over liters, which is 0.025 over 0.1200. Notice this also helps me. Moles over liters, moles over liters. So you can always use those units to figure out what's going on. 0.025 divided by 0.1200 gives me 0.208 molarity, big M, or 0.208 moles per liter. Both are acceptable. Sig fig wise, 2 sig figs, 4 sig figs. So my answer can only be in 2 sig figs. 0.21 is going to be my molarity. So now, what do I know about molarity? Concentration of HBr is equal to 0.21 molarity. Concentration of HBr is strong acid, which means concentration of HBr is equal to the concentration of H+. Only do this with the strong acid, so always make sure you note hydrobromic acid is a strong acid, so the concentration of HBr is the concentration of H+. So that means the concentration of H+ is 0.21. So up here, 0.21, 2 sig figs. Still make sure you're doing your sig figs. What's my only conversion I can do from here? H+ goes to pH. pH is equal to negative log of the concentration of H+. Negative log 0.21. So, negative log 0.21 in parentheses. So my calculator, it looks like that, negative log 0.21. If you're using your phone or another device, it might go the other way around. You might hit 0.21, then the log button, and then the minus button. And that's going to give me 0.677 for my pH. So super, super acidic. Because remember, 0 to 7 to 14. 0 to 7 is an acid. 7 to 14 is a base. It's blue and bitter with litmus paper. Not that you'd ever taste it. So that's a really, really acidic solution. But I only need 2 sig figs, so 0.68. So my pH up here, 0.68. So now I have my pH. I now have my hydronium. My next equation, if you have pH, you can find pOH. If you have pOH, you can find pH. pH plus pOH equals 14. Okay, so my pH, 0.68 plus pOH equals 14. And that is going to tell me that it is 13.32 is going to be my pOH. Okay, 2 sig figs gives it only a 13. Okay, so 13 for my pOH. So pH shows it's very acidic. Okay, so it's going to have a high pOH number, just like the reverse. Make sure you're paying attention. Hydrobromic is a strong acid, so the concentration is H+. But if I had given you a base that was a strong base, then its concentration would be OH-. So make sure that's a critical point that people mess up when they get here. Make sure you know if you're calculating concentration of OH, because that's going to give you pOH. We're calculating the concentration of H+, so we get pH out of it. And then for the concentration of OH-, that's our other formula. 10 to the negative pOH. 10 to the negative 13. Which is 1 times 10 to the negative 13 in scientific notation. But remember, sig figs, we need 2 sig figs. 1.0 times 10 to the negative 13. So our concentration, 1.0 times 10 to the negative 13 is our concentration of our hydronium. So now you have all 4.